Okay, so this video is about the remainder theorem. I'd advise you watch the one on the factor theorem first if you haven't already. So let's say I'm trying to factorise this cubic, x cubed minus 7x minus 6. Might look for an integer root and find that x equals 1 works here, 1 cubed minus 7, oh sorry, x equals 1 doesn't work, x equals minus 1 works, so minus 1 plus 7 minus 6, that's 0. So that means that x plus 1 is a factor. Now I can factorise this neatly into with a quadratic here, so I can say, okay, this must be x squared, this must be minus 6, and now I just got to make this middle term work. So to get my minus 7x here, well, x times minus 6 is minus 6x, so I need another minus x, so 1, so if I say 1 times minus 1 does it, so I've got minus x in there, and you can check that that works. If you find these ones a bit odd, by the way, when there's not something missing, feel free just to write in plus 0x squared if that helps you at all. And so I get a nice thing here. Now I can factorise this, and I get x minus 3 times x plus 2, and I can find the other two roots. Now, so that's great. Now, what happens though when I try to pull out a factor that isn't a factor, right? Because this is a bit like division, isn't it? So what I'm saying is x cubed minus 7x minus 6 divided by x plus 1, that's x squared minus x minus 6, or it's x minus 3 times x plus 2. So she's saying if I divide this by x plus 1, I'm just left with this. I'm just left with these two, right? Now, as with numbers, we can divide numbers by other numbers that aren't factors, and we can do the same thing for polynomials. So here's something that x plus 1 is not a factor of, but I could start doing my division. Now some people do this by a long division method. I quite like to just multiply it out term by term like this, so use whichever method you prefer, but hopefully you can follow this. I know this must be 1x squared because it's x times x squared. Now to get my next term I need x cubed because it's x times x squared, and to get my next term 5x squared, I've already got plus 1x squared, so I need another 4x squared. So I'll put a 4x term here so that when I multiply it out, 4x times x gives me that 4x squared. Next term I've already got 1 times 4x, so that's 4x. I need to have 1 fewer x, so I'll do minus 1, and that will give me my minus 3x, my plus 3x term here. And now 1 times minus 1, that's minus 1. That's not minus 2. But we didn't expect it to be because we know x plus 1 isn't a factor, right? So this isn't going to work exactly. So I've actually got, I need one more, I need to subtract another 1 on the outside here. Okay, so I get this term here. So this, is the remainder, when we divide this by x plus 1. Alright, so if you like, if I do x cubed plus 5x squared plus 3x minus 2, all divided by x plus 1, in kind of primary school maths sort of words, that would give me, x squared plus 4x minus 1 is my quotient, and its remainder minus 1, that's the remainder. In algebra, I would probably write that as, plus minus 1 over x plus 1. This is all equal to this. So if I do say 43 divided by 7, I get 6 remainder 1, don't I? So that's like, because so 43 sevenths, that's just 6 and 1/7, the same sort of thing here. I'm dividing by x plus 1 and I'm getting to the equivalent of 6, which is the equivalent of my remainder sevenths. Now, because it's algebra, I can end up with negative remainders. If I divided by a quadratic, I could even have some algebra in my remainder, but when it's a linear term, we just get a number. Okay, so the question is now, what's the significance of this minus 1? I'm getting, this is a lot of motivation. So it's about time I told you what the remainder theorem actually says. Now, so here's my x plus 1, and I've divided by x plus 1. Now for the factor theorem it said I could put minus 1 in here and I'd get 0. Now, you see when I put x equals minus 1 in here, what I'm going to get is whatever this remainder is. Because x minus 1 in this bracket is going to give me minus 1 plus 1, that's 0. And in this bracket, it'll give me some other number. Doesn't really matter because it's times by 0. It would be 1, it would be minus 4. But it's 0. And then I'll just get this minus 1. So I'm going to be left with minus 1. And indeed, you can check if you put minus 1 on this side as well if you're not convinced. Minus 1 cubed plus 5 times minus 1 squared plus 3 times minus 1 minus 2, that's minus 1 plus 5 minus 3 minus 2, that is minus 1. So what the remainder theorem says is that the remainder, when you divide by this factor, x plus 1, is what you get when you put minus 1 into this polynomial. So it works very much like the factor theorem, it's just rather than getting equals 0, I'm getting this remainder. In fact, the factor theorem is a special case of this theorem, because if I get 0, that's like having remainder 0, so if that's 0, then I've got a nice exact factor. So, for example, if I wanted to find the remainder when x cubed minus 3x squared plus 4x minus 2 is divided by x minus 2, all I've got to do is take the number in here, minus 2, make that positive, i.e., well, do minuses, so it's minus minus 2, so that's plus 2, and put 2 into here. So the answer here would be 2 cubed minus 3 times 2 squared plus 4 times 2 minus 2. Okay, that's 8 minus 12 plus 8 minus 2, so that's 16 minus 14, which is 2. Just coincidence that these numbers have come out the same both times. In the previous one I put in minus 1 and I got out minus 1. Here I've put in 2, I've got out 2, that's coincidence. This number could be anything. So that's how the remainder theorem works. Here's a good sort of exam style question. The remainder when x cubed plus ax minus 2 is divided by x plus 3 is 13. Can we find this number a? Well, the remainder theorem says that the remainder is just what I get when I put in minus 3 into here, because it's x plus 3, so I take that and make it minus. So if I do minus 3 cubed plus a times minus 3 minus 2, that's putting minus 3 in here, that's the remainder, so I'll get 13. So this is minus 27 minus 3a minus 2 is 13. So let's put the 3a over here. Minus 27 minus 2 is minus 29. Minus 13 is minus 42. So I just need to divide by 3 here. And that gives me minus 14. So that's the value of a. Okay, so this is, to summarize the remainder theorem, when I divide the polynomial f of x by x minus a, what I get is f of a, i.e. whatever I get when I substitute in that value a into the polynomial. Okay, hope that was useful. There are lots more videos on the website.